Lesson 2-6, Ratios and Proportions. A ratio is a comparison of two numbers by division. So there's three different ways that we can write ratios. We can write them in word form. So x to y, so you replace the numbers, maybe 3 to 2. Or you can have x, and we read this x to y, but it looks like this. Or you can have x over y, which can also be read as x to y, or x divided by y. A proportion is an equation stating that two ratios are equal. So, for example, we have 0.349 over 10,000. Well, this shows that 3.49 over 100,000 and 0.349 over 10,000 are equal. Because if you move the decimal point for this example here, you get 3.49. Well, when we move the decimal point up top, we have to move the decimal point one place here, which would add a 0, so they would be equivalent. So let's take a look at these two examples. Here you want to determine whether the ratios are equivalent or not. How we do that is to take the fractions and write them in their simplest form. If they're in their simplest form and they're the same, they would be considered equivalent. So the first one we have is 6/10. So if we write 6/10 in its simplest form, we can divide the top and the bottom by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. We're not able to go down anymore. And the other fraction was 2/5, so we would say that they are not equal. So you can either say no, or you can write an equal sign with a line through it, meaning that they are not equal. The next example is 1/6. So 1/6 is in its simplest form. Now we have to simplify 5/30. So if we divide the top by 5 and the bottom by 5, we get 1/6, and that's exactly what we were looking for. So we are able to say that those are equivalent fractions. So you could say yes, or you could just demonstrate it with an equal sign. So there is a property that goes with ratios and proportions, and it is called the means extreme property of proportion. So in a proportion, the product of the extremes is equal to the product of the means. So what that means is if you have A over B, and if that is set equal to C over D, so they are proportionate, and B and D are not 0, so they can be any other number other than 0, then that means that A times D is equal to B times C. So it's a cross multiply thing. And we'll see a few more examples in the next couple slides. So here it says cross products to determine if the ratios form proportions. So this is a number form of the previous example. So if we have 2 over 3/5 and 8 over 14, we're trying to determine if they form proportions. So to do this, you first set them equal to each other, which we're not sure if they're equal, so that's what we're trying to determine. So we start out by cross multiplying, so the tops times the bottoms. So we first have 2 times 14, and we're trying to determine if that is equal to 8 times 3.5. So we know that 2 times 14 is 28, and if we solve for 8 times 3.5, that is also 28, so we could say that they are equivalent to each other. Pause the video to try a few examples. Cross products to determine if each pair of ratios forms a proportion. So the first example we have is 0.2 over 1.8 and 1 over 9.9. So if you cross multiply, we have 0.2 times 0.9, and we're trying to determine if that's equal to 1 times 1.8. Well, 0.2 times 0.9, 9 times 2 is 18, and then you have your two decimal points equal to 1 times 1.8 is 1.8. So we can see here that these are not equal to each other. The next example we have is 15 over 36 and 35 over 42. When you cross multiply these, you should have gotten 15 times 42, which would give you 630, set equal to 35 times 36, which is 1,260, and those are not equal to each other. So when we are solving proportions, you can also use cross product, just like we did in some of the previous examples. So you cross your numerators to your denominators. So we crossed and we had 3 times 10 equals 5 times x. 3 times 10 equals 30, and your 5x is left. Now you can begin to solve for your x. You divide both sides by 5, which leaves us with 6, so x equals 6. We can also figure out rate of growth, or the change in something. So let's take a look at this example below. It says in 7 minutes, it takes Isabella 7 minutes for her to walk around the gym twice. At this rate, how many times can Isabella walk around the track in a half an hour? So we first want to set up our proportion. So in 7 minutes, she can walk 2 laps. We want to know how many laps, so we'll just say x laps, can she walk in a half an hour. But since they originally gave it to us in minutes, we want to turn that into minutes. So with that, we get 30 minutes. So now you can go in and cross multiply. So we have 30 times 2 equals 7 times the x. 30 times 2 is 60, divided by 7, or times 7x. Divide both sides by 7, and we have 60 divided by 7. I'm going to take it over here so we can long divide it out. 7 goes into 60 8 times, and we get 56. 4 left over, so we add our decimal point, we bring down the 4. 7 goes into 40 5 times, and then anything after that would be, you would have to round. So we could say that she could go approximately 8.5 laps in 30 minutes. So scale and scale models is something else that we're going to talk about. A rate called a scale is used when making a model of something that is too large or too small to be convenient at an actual size. So a lot of times we will hear of scale models when someone is drawing maybe a layout of a house or the dimensions of an area. They will use scale drawings. A scale model is a three-dimensional reproduction of an item that has been reduced or increased in size proportionally. So let's take a look at this example of scale models together. On a model airplane, the scale is 5 centimeters equals 2 meters. So we first want to write that out. 5 centimeters equals 2 meters. If the wingspan of the model is 28.5 centimeters, so you want to keep your units together. So if one side is centimeters, if they give you dimensions in centimeters, that's where you put it in the proportion. This is what is the actual length. So now we use our cross products to solve. So 28.5 times 2 and 5x. I'm going to come over here and write out that 25 times 2. So you have 5 times 2 is 10. 8 times 2 is 16 plus 1 is your 17. And 5. So 57 equals 5x. Divide both sides by 5. So 57 divided by 5. 5 goes in the 5 one time. 5 goes into 7 one time with 2 left over. And then 5 goes into 20 4 times. So we would say approximately 11.4 meters is what is the actual wingspan of the airplane. Pause the video to complete the lesson review.